In this video, we're going to go over these notes on linear systems. So it's going to be rather quick because the notes are already created. Question: what is a system of linear equations? An answer is a collection of at least one linear equation. More specifically, for integers m greater than 1 and n greater than 1, a system of m linear equations in n variables has the form a11x1 plus a12x2 plus and so on plus a1nxn equals b1. That's the first equation. a21x1 plus a22x2 plus and so on plus a2nxn equals b2. That's the second equation. All the way down up until the mth equation. am1x1 plus am2x2 plus and so on plus amn xn equals bm, where each of aij's and bi's are real or complex constants for all values I from 1 to m and j from 1 to n. But notice that at least one of the coefficients of each of the equations is different than 0. We refer to such a system as an m by n linear system, or simply as a linear system. I already pronounced this as m by n. For instance, a system of two linear equations in three variables, or a 2 by 3 linear system, has the form: there are two equations in three variables. In this case, variable x1, x2, x3. Now, a solution of such an m by n linear system is an n-tuple, x1, x2, all the way to xn, equals to a1, a2, an, such that the constants a1, a2, all the way to an are solutions of each of the m equations. Example: determine whether the given 3-tuple is a solution of the system. This is a 2 by 3 system. For number 1, the 3-tuple is 3, 2, -2. So is that 3-tuple a solution of our 2 by 3 system? In this case, 4x1 plus 3x2 plus x3 equals 16, and x1 plus 5x2 minus 4x3 equals 21. Okay, so my x1 is 3, my x2 is 2, my x3 is -2. Now we're plugging in each of these values into each of these equations. So let's let's try to be efficient here. Is it the case that 4 times 3 plus 3 times 2 plus negative 2, is it the case that that equals to 16? Calculating 4 times 3 gives you 12, plus 3 times 2 gives you 6. So 12 plus 6 is 18, but then you're subtracting 2, that gives you 16. So far, 3 to negative 2 is a solution of the first equation. That doesn't mean that this is a solution to the system until we're also able to verify that that same 3 tuple is also a solution of the second equation. So let's check. So is 3 plus 5 times 2 minus 4 times negative 2 is that equal to 21? Let's do the calculation. Here you have 3 plus 10. 3 plus 10 is 13. Then plus 8. 13 plus 8 is 21. So we conclude that 3 to negative 2 is a solution to our given linear system of equations. Now, in our second one, we have 2, 1, 5. In that case, the answer is no. So the first one answers yes because the given 3 tuple, 3 to negative 2, was a solution of both equations. But 2, 1, 5 fails to be a solution of the second equation. Notice that 2 plus 5 times 1, which is 5, so 2 plus 5 is 7, and then minus 4 times 5, which is minus 20. 7 minus 20 is a negative number, not 21. Okay, so here is our goal, to be able to find solutions of a linear system, if any. Now, we do have the familiar elimination method. So what we know is that when we have a system of linear equations, we can solve it by using a certain mechanical method. So let's try it with this first example. Solve the given linear system. So in here, I have x1 plus 2x2 plus x3 equals 4. 4x1 plus 6x2 plus 6x3 equals 5. And 4x1 plus 3x2 plus 2x3 equals 1. Okay, so this is going to be the familiar elimination method of algebra, of pre-calculus algebra. Okay, so first let's eliminate the first column. Let's eliminate x1, which pretty much means get rid of the 4's below the first non-zero term 1. So I can apply the elementary row operation R2 minus 4R1 to get rid of the 4 in the leading 4 in the second row. I can apply a similar elementary row operation by saying R3 minus 4R1. So I'm doing two elementary row operations at once here just to get rid of these 4's. 4 minus 4 is 0. 6 minus 8 is negative 2. 6 minus 12 is negative 6. 5 minus 16 is negative 11. Okay, so that one's done. Now, 4 minus 4 is 0. 3 minus 8 is negative 5. 2 minus 12 is negative 10. And 1 minus 16 is negative 15. Okay, now eliminate x2. Now the way we go about it is we try to make that a 1 and then use it to eliminate the 2 above it and the negative 5 below it. So to get a 1 in there, we just have to multiply the second row by negative 1/2. So we get 0, 1, 3, 11 over 2. Okay, now we're ready. Okay, so to get rid of that 2, I'd say row 1 minus 2, row 2. Row 1 minus 2, row 2. And to get rid of the 5 below is a row 3 plus 5, row 2. Okay, so let's work with this first. So row 1 minus 2, row 2. So 1 minus 2 times 0 is just 1. 2 minus 2 is 0. That was the purpose. That was the goal. Here we have 3 minus 6, which is negative 3. And then we're multiplying a row 2 by 2, so that becomes by negative 2, so that becomes negative 11. 4 minus 11 is negative 7. Okay, so we're done with that one. Now, 0 plus 5 times 0 is 0. Negative 5 plus 5 times 1 is 0. Negative 10 plus 15, because 5 times 3 is 15. Negative 10 plus 15 is 5. Negative 15 plus 55 halves, because 5 times 11 over 2 is 55 halves, is equal to, in here I'm going to get negative 30, because the denominators need to be the same. So we get negative 30 plus 55 over 2. So 55 minus 30 is 25. So we end up with 25 over 2. Okay, so that's done. Okay, so now our last elimination is to eliminate x3. Here, I forgot to write that we were eliminating x2. That has been accomplished. Now we want to eliminate x3. Okay, we're going to make some space for that. Let's do it here. Okay, so Let's make this a 1, so multiply row 3 by 1/5. So we end up with 0, 0, 1. The 5's cancel, so you end up with 5/2. Okay, now we're ready to get rid of this 3 and that -3. So to get rid of the -3 in the first row, you just say row 1 plus row 1 plus 3 row 3. To get rid of this 3 in the second row, third column, you will have to say row 2 minus 3 row 3. Okay, so here is the result. 1 plus 3 times 0 is 1. 0 plus 3 times 0 is 0. -3 plus 3 is 0. So here we have -7 plus 3 times 5/2, which is 15/2. Now, that becomes -14/2 plus 15/2 is 1/2. Okay, got that. Now, row 2 minus 3 row 3. 0 minus 3 times 0 is still 0. 1 minus 3 times 0 is still 1. 3 minus 3 is 0. Now we have to do 11/2 minus 3 times 5/2. -3 times 5/2 is -15/2. So you end up with -4/2, which is -2. Okay, so that's done. 0, 0, 1, 5/2. Okay, now that this matrix is reduced, this is actually what we call a reduced row echelon matrix. We can easily read our solutions. x1 equals 1/2, x2 equals -2, x3 equals 5/2. So our solution as a 3-tuple, we could say is a 1/2, -2, 5/2. That took a little bit long. Now, in our second example, we have a 2x3 linear system. We can still use the same method displayed in our first example, write what we call an augmented matrix, use the familiar elimination method to obtain a reduced row echelon matrix, and then from there we can easily read off solutions. So let's try that now. I'm going to write the augmented matrix for number 2. So first column is 4, 1. Second column is 3, 5. Third column is 1, -4. And then the last column is 16, 21. Okay, so I want this one to be at the top left. So let's interchange the 2 rows. Okay, Now, eliminating x1, that's what I want to do. Eliminate x1, get rid of that 4. So I will do it by taking row 2 minus 4 row 1. 4 minus 4 is 0. 5 minus 20, excuse me, 3 minus 20 is negative 17. 1 plus 16 is 17. 16 minus 84. So 16 minus 84. The answer is negative. So here we're gonna get 68. All right, so we have 1, 5, negative 4, 21. Okay, now let me make this a 1 now so that I can use it to eliminate the 5. So take a row 2 and multiply by negative 1 over 17. So I end up with 0, 1, 1. And then negative 68 over negative 16, that's a positive number. I hope it's a nice value. Probably it isn't. We have 68 over 17. Oh, it is a nice number. It's 4. Okay, so it's 4. Here there is a negative. So you have 17 times negative 1 over 17. That's a negative 1 there. Got to be careful with your signs. And then 1, 5, negative 4, 21. Now we're going to eliminate eliminate x2. So eliminate x2. So that's 5. The way to do that is to take row 1 minus 5 row 2. Okay, so 1 minus 5 times 0 is 1. 5 minus 5 is 0. Negative 4 plus 5 is 1. 21 minus 20 is just 1. Then you still have 0, 1, negative 1, 4. Okay, there is no more elimination. There is no more elimination as possible here. So what did we get? Well, we got this reduced row echelon form matrix, but we also got a system of equations out of it. That's x1 plus x3 equals 1. x2 minus x3 equals 4. So let's write that in here and come up with three tuples solutions as triplets. Okay, so this is x1 plus x3 equals 1. Now, I want to solve for x1 and I want to solve for x2 in terms of x3. So here, that's the same as x1 equals negative x3 plus 1. In our second equation, we're going to get x2 equals to, when I have x2 minus x3, but when I move x3, that becomes x2 equals x3 plus 4. So the variable x1 depends on x3, the variable x2 depends on x3. x3 it's free. x3 is free. It could, if we're solving this in the set of real numbers, then x3 is a real number. If we're solving this system in the complex number in the complex numbers, then we obtain x3 is a complex number. Okay, so solution, the solution set here is all triples 1 minus t 4 plus t such that t is free. I'm going to pretend for the sake of this presentation that we're in the set of real numbers. All right, some terminology which are already used in our examples. When we have an n by n linear system, the matrix that we obtain by using the coefficients in the right side of the equation is called the augmented matrix of the linear system. That's given. Okay, that's all for now. Thank you.